वेलकम ऑल। और आज का जो टॉपिक है वो है सेट से कैसे कॉम्बिनेटोरिक्स को रिलेट करें। सो लेट्स सी अ ब्यूटीफुल प्रॉब्लम। वी हैव टू सेलेक्ट नंबर ऑफ triplets of the sets ABC such that it follows some guardianship. ABC themselves are subset of 1, 2, 3 till 8. The number of elements in A intersection B, B intersection C, and C intersection A is 2, and number of element in A, B and C, they are same, and that is 4. So based on this guardianship we need to find number of such triplet. So here of course we'll do case making. तो पहले इस टाइप के प्रॉब्लम को सॉल्व करने के लिए मेरे पास दो आइडिया है। जब कभी भी सेट और सबसेट का क्वेश्चन आए तो सबसे पहले वेन डायग्राम बना लेंगे, उससे यू कैन इजिली सी द लॉजिकल फ्लो ऑफ द इंफॉर्मेशन. So we know we have three sets A, B, C, and all the elements are coming from the master set S, which is 1, 2, 3 till 8. So we can select the subset from this superset of S, right? Okay, so let's go. So what I'll do is first I'll segregate the regions. So these three circles divides the entire universe into 8 parts. क्योंकि आप देखो कोई भी set in any part will be either present or absent. This is also a combinatorics logic. Similarly, in any region, B will be either present or absent, or C will be present or absent. So in total, we'll have 2 into 2 into 2. So there is 8 regions in which these 3 circles will divide the entire universe into. In fact, it's an interesting problem to ask for 4 circles and you are expected to give the answer of 16. But can you really draw Venn diagram with 4 circles? Think about it. In fact, the answer is negative. You can't do it. So you have to bring ellipse into picture or something else. That will be our agenda of some other class. Okay, so first I'll segregate into regions. So let's say R1, R2, R3, R4, R5, R6, R7, and outside region is R8. Now we want number of element in AB, BC, and C8 should be 2. And set ABC should contain 4 elements each. तो इसके लिए what I'll do is I'll start segregating based on number of element in this region R3. So how many elements are possible in R3? Either we'll have 0 element or 1 element or 2 element. 3 element तो possible ही नहीं होगा, because if R3, which is basically A intersection B intersection C, has more than 2 elements, then how R3 plus R4 will have 2 elements? So that's not possible. Hence I'll have only 3 cases. Either R3 will have 0, 1 or 2 element. Remember, I am using a notation mod x as cardinality or number of element in set x. Cardinality of set x. Cardinality is a fanciful number, which denotes number of element. तो if R3 के पास अगर 0 element है तो चलो अब हम इसको ऐसे बनाते हैं. If I have 0 element over here, so how many object will have in R4? Clearly it will have 2. Because sum has a 2. Similarly, R6 will have 2 and R2 will have 2. Now, how many will have in set B? It's already 4 because R2 and 2 makes 4. So, in this entire region, we have 4 elements. And same goes for all the 3 regions. So, in this case, with R3 as 3, it's quite easy to count. क्योंकि मेरा जो आंसर आएगा वो out of total 8 elements present in set, I'll give nothing to this common region R4. So I'll give 2 to R4, 8C2. Ways are there? Remaining I have 6. So out of 6 again R6 will take 2 element and I'm left with 4 elements, and that way I'll give to region R2, which is 4C2. Now this automatically takes care about the ordering as well. क्योंकि मान लो अगर हम इसको 1 2 दी and 6 I have given 3 4 and this I have given 7 8 like R2, so that is already taken care of, and in fact I need the order. So this is the total number of ways in which we can allocate corresponding to n equal to 0, and if we calculate this comes to be 2520. That's about case 1. Now let's move to the case when number of element common to all the 3 sets is 1. That's not also difficult because we have to give 1 element here. So now since the common part has to be 2, so 1 element each will go. And now since all these sets has to have 4 elements, so I have to give 1 to the remaining set, this region, right? So again, so we have 1 2 3 4 5 6 7. So there are 7 distinct ways in which we can arrange them. So basically, let's say if I start with this, out of 8, there is one way. I'm left with 7, then I'll give to the circled one in 7c one ways. I'm left with 6c one ways. Again, I'm left with 5 elements, so any element can go here, 5c one ways. Now left with 4 elements, so 4c1, we have 3c1, and then finally 2 choose one way. So this will give you the answer 8 into 7 till 2, which is basically 8 factorial. Even if 1 is not coming, but I still factorial wise 8 factorial. And that will give you 40320 ways of doing so. You can also look upon this from different perspective, because anyway all these 8 regions has to be distinct, because it matters whether 1 is going here, 2 is going here, 3, 4, 5, 6, 7 or any other way. So you can imagine this 7 distinct region as 7 distinct boxes, 1, 2, 3, 4, 5, 6, 7. Am I right? Yeah, 7. And now I have in a box containing numbers, digits from 1 to 8. So for the first place, any 8 can go, then 7 can go. Third will have 6 options, 5 options, 4 options, 3 options, 2 options. And since all these are independent, so I can just multiply it by principle of multiplication. तो यहाँ से अपने पास 8 factorial भी जाएगा. Now last is when number of element common to all set is 2. So when we have 2 objects over here, now clearly we can't have anything over here, anything over here and here, because that must be empty. Since set ABC must have 4 object is, so I must have 2 object over here, 2 here, and this 2 here. Remember, these 2 are not identical, so this is also different, right? Yeah. So now in how many ways we can do this? Fairly easy. Out of 8, first you select 2 elements, give it to this common region. Now we are left with 6. Again, any 2 can go to this region. Left with 4. Any 2 can go to this region. By the way, how will you describe this region? This is a region which is present in A, but not in B and not in C. This is the region which is present in B, but not in A, not in C. Similarly, this region is present in C, not in A, not in B, and this guy is present in all 3 A, B, C. This is a typical mathematical language of representing the sets or the region with the set description. So 8C2, 4C2, and now I'm left with again 2, so 2C2. And this if we'll calculate, I've already calculated for you. You'll get the answer of 2520. And all these 3 cases are mutually exclusive because there is no overlapping in first case. In first case, number of intersection was 0. In the second case, all A intersection B intersection C was 1, and third cases was 2. So of course there is no way that any configuration of first case will match with the second or third. And that's very important. The basis of discrimination should always be mutually exclusive as to avoid overcounting or undercounting. And if I add all the 3 guys, you'll get answer as 45,360 ways are there to accomplish this event. And that's the answer for this beautiful problem. The similar problem in this sprint was asked by JEE Advanced, where they have asked the questions based on independent events, right? So I have not done this because I want you to try this by yourself. You can check any permutation combination booklet where they have defined a set and they ask the number of ways in which these events will be independent. So precisely number of ways in which A intersection B element will be intersection of A, number of elements in A into number of elements in B, provided the experiment is uniformly distributed and randomly selected. Thank you. Have a good day.